Welcome back, everyone. In this lecture, we're going to go through the solutions for the text classification project exercise. Let's head to the notebook and get started. Okay, here we are at the text classification assessment notebook. Let's go ahead and start by just importing the data. We can essentially just run these cells since it's already filled out for us. And we can see here we have that data we talked about, the text review in raw text, and then the label either negative or positive review. So first things first, I want to check to see if there's any missing values in the data frame. And really what we mean by that are just classic missing values, that is not a number, that is that nan. So we can do this by saying df is null and just check the sum as we've done a bunch of times in previous projects. And we can see here that right off the bat, there's 35 reviews that are not just empty strings, but they literally don't have any information there. So what we can do is just remove any reviews that are null or nan. So I can say df is equal to df drop na, which is really the only option we have here because we can't really interpret anything that's just missing all the text. That's essentially just missing all the features. So we're going to say df is equal to drop na, which means if I say df is null, and then do a sum check here, I should get 0, 0. Now, we should be very careful when it comes to text data because often when it's stored in a database, if there is no text data, sometimes it's stored as an empty string or just a string of a single space instead of actually leaving it as a nan data point or null data point. So that's why we have this next task for you because it's actually something really common to do, which is to check to see if any reviews are blank strings and not just nan. So I want to actually add the note here that the review text could be an empty string, just two quotes right next to each other, or there could be a space between them, or some even larger blank string. So how do we actually check for this? Well, I did mention there are many ways, but hopefully if you've done a quick Google search, you would have eventually found that you can check if there is a space in a string in normal Python with the isSpace method. So what I mean by that is if we come back here and just assign an empty string with a bunch of spaces, so this particular string has a bunch of empty spaces, what I can do here is say s is space, and this is already built into normal Python, not just pandas, and it returns true if it happens to be some sort of number of spaces. So even if we make this a huge number of spaces, run that, it will also return true. And the one thing to note here, if there is no space, it's just an empty string, isSpace is actually going to return false. So we'll have to figure out one additional way to check for an empty string, which is actually pretty easy using what we know about apply. We can just do a direct check to see if it's an empty string. The tricky part was figuring out isSpace. That way you don't need to check for any number of possible blank spaces. So let's first figure out isSpace and how we can use this pandas str isSpace to help us out. So what we're going to do here is the following. We're going to grab our data frame. So what we're going to do here is say df, and then just grab that review column. So it's called review. And again, here's the review. Some of them are spaces, so we can say .str.isSpace. Whoops, is space here. Make sure we spell this right. There we go. And when you run this, it's a bunch of booleans, which means I can pass in this series of boolean values, and this is going to return back the index locations where it happens to be some sort of blank string, where it's just a bunch of spaces. Obviously, this is not going to be helpful for our model to figure out whether a completely blank string review is negative or positive because there's no real information. This is akin to missing every single value for every single feature, because eventually after TF and IDF, every word kind of acts as its own individual feature. So what we're going to do is just get rid of these. And the way we can do this is recall from a long time ago when we discussed pandas, we did mention to get the inverse of this, you could add this tilde symbol here, and this returns essentially the opposite. So everything that isn't in that. Obviously, you could also just run the index selection and done it that way, but it's probably the simplest way to do that. So what we're going to do is reassign df equal to every instance in the data frame where the review is not just an empty string or an empty space. So we'll go ahead and run that, and we still have the possibility that the review is a completely empty string. Recall isSpace does not check for that, but we can easily check for that by saying df review and simply apply our own quick check. So we're going to say apply. You can do a full function here or just a quick lambda expression, but I'm going to say lambda where the review, and I want to return, is the review equal to just an empty string. So again, you can run that, get a bunch of boolean values, and we can pass that into the data frame and just see if anything is returned here. And notice nothing is returned, so you don't actually have this issue of anything being an empty string. We did have the issue of things being kind of blank strings, but we don't have any issue with the empty string. And we just did that with a quick check here of checking, is the review equal to just an empty string? Notice there's no space here between these two quotes, which means I don't actually need to worry about that particular aspect. Okay, perfect. So what we're going to do is now check out the info of our data frame and see if it matches up with what we have here. Run that, and we have 1,938 rows. And let's confirm the value counts per label. So we're going to say df dot, and then let's check the column against label. So we're going to say label, and then call value counts here. Run that, and you should see it's actually perfectly even, 969. So don't worry about that. We kind of marked the data in a way that it would be correct, that you get exactly as many negative reviews as you do positive reviews, even after taking care of those blank strings, since we added those in manually. Okay, so it looks like our data is ready to go. We have this bonus task of EDA on a bag of words. And so for this bonus task, we asked you, can you figure out how to use a count vectorizer model to get the top 20 words that are not English stop words per label type? Note, this is a bonus task because we didn't actually show you how to do this in the lectures, but any cursory Google search would actually really point you in a lot of correct directions on this. And in fact, we have this click me for a big hint, which is a Stack Overflow post that pretty much gives you the answer. So if you come back here, this person asked a long time ago, actually over almost 8 years ago, find the most common term in scikit-learn classifier. It's basically this person's asking, hey, I have this count vectorizer. How do I actually view all the terms and their frequencies? So how do I sort them by number of occurrences? And then we have, if you scroll down here, basically the direct answer. Now keep in mind, this is for returning every single word and their frequency count. What we actually want to do is just the top 20, and we also want to make sure we do it per label category. So there's a couple things we have to edit here. And the other thing, note, is there's a comment that to fix this correctly, we should be saying matrix.sum along axis equal to 0, toList, and 0, because it's just matrix.sum is returning a matrix, and we want this as a single list. So let's copy and paste this code, see if we can understand it and what's actually happening here. So I'm going to copy and paste this back over here. Let's create another cell and see what this person is doing. So we have count vect.fit transform, and clearly count vect here is the actual count vectorizer model. So in fact, let's go ahead and just import that from sklearn.featureExtraction.text import count vectorizer. Okay, so we have this count vectorizer, and let's make a quick instance of it so it matches up with what's shown here. Count vect is equal to count vectorizer, and then recall I don't want those English stop words, so we're going to say stop words. Stop words is equal to English. There we go. Okay, so now you have this count vectorizer, and what is it doing? It's simply fit transforming on that list of documents. So what are our documents? Well, the documents is just the review column. So if you go back to your data frame somewhere around here, note that the list of documents is just this column of all these reviews. So what I'm going to say here, when I scroll back down, is instead of doc list, I'll say this is equal to df review. However, is it just the review column that I want? Technically, no. Recall I asked this per label type. So what I first need to do is filter this out per label. So we're going to say df, where df, oops, make sure those are square brackets, where df of label is equal to, and then the first one we can do is negative. And then after performing that filtering, then we pass in that review. And so this is our document list of all the negative reviews. So that gives us this matrix, which recall is a sparse matrix. And then what this user is going to do is they're going to combine the get feature names, that is all the words, and then they're saying matrix.sum axis equal to 0, essentially counting up all those occurrences of the words. And again, as I mentioned here, we want to add in this toList 0 to make sure we actually get this as a list, because the very next line, what it's doing is it's going to sort them, essentially all the counts, from largest to smallest. And this is doing it for every single word possible in the reviews. So we don't actually want it for all the words, we just want it for a top 20. So what we're going to do is after it's sorted, we're going to say starting from the beginning, go all the way up to 20. And note that they forgot to put the parentheses in print. It's actually a Python 2 issue to Python 3, but that should fix it for us. So again, what we're doing here is we're simply saying fit transform all the negative reviews, go ahead and zip together to count the feature names along with the actual word that get the feature names, and then sort them from largest to smallest. So if you run this, it'll take a little bit of time, but eventually you should get a matchup here to see film shows up this many times throughout the negative reviews, movie shows up this many times, like shows up that many times, etc. And to see this for the positive, you simply replace neg with POS, run that, and you can see the positives. And as we mentioned in the overview lecture, it makes sense that words like film and movie are the most popular both for negative reviews and for positive reviews. Okay, I hope that helps you feel comfortable with finding out other solutions online, such as Stack Overflow posts, and then conforming them to figure out how you can match them up with your particular situation. That's a very important skill to have as a developer. So we're going to scroll down here and move on to training and data. So we split the data into features and the label. This part's pretty easy. All we're going to say here is x is equal to df review and y is equal to df label. Then after that, we'll say from sklearn.modelSelection import train test split, call train test split, and let's go ahead and expand on this till we get to right here, this tuple. Go ahead and grab that information. I'm going to paste that in. And we mentioned that the solutions use a test size of 20% and a random state of 101. So let's go ahead and just match that up. And there we have it. Okay. So we have model selection, import train test split. We have xtrain, xtest, ytrain, ytest. So now it's time to create a pipeline that allows us to both create the TF-IDF vectorization out of the raw text data and fit a supervised learning model of our choice. So there's going to be a couple things we're going to have to import here. We're going to say from sklearn.pipeline import the pipeline object, or the pipeline class really. Then we're also going to say from sklearn.featureExtraction.text import TF-IDF vectorizer. Recall we don't want transformer because that implies we've already done count vectorization. I'd rather do it all in one step as we've done in the previous lectures. So I call it TF-IDF vectorizer. And then finally, you get to choose any model you want. Let's go ahead and just choose linear support vector classifier because that's what matched up with our particular solution. And we're not even going to do any grid search, but obviously you could do that as well, given what you already know about grid search, cross-validation, etc. So we're going to import the pipeline and the two classes going into the pipeline. So we run that, create the pipe object, say pipe is equal to pipeline, and then start passing in the list of models. So first we do TF-IDF, call it whatever you want. So we'll say TF-IDF vectorizer. And then the second thing we do here is we say SVC, and then we're going to call linear SVC. And there we have our pipe ready to go. So we're going to say pipe, and we're going to fit it onto xtrain and ytrain. And what's really nice about this is recall xtrain is the raw text data, and I can fit it to my pipe because it's performing that vectorization first. Okay, so we go ahead and run that, and we have it ready to go. So that's fit to the training data. And now let's create a classification report and plot a confusion matrix. Done this a bunch of times here. We can say from sklearn.metrics import classification report, and then we're also going to import plot confusion matrix. So then plot confusion matrix, and let's run this by creating first a set of predictions. So we're going to grab our pipe here and predict xtest, run that, and let's print out our classification report here. It's going to take in, oops, that's not the print here. So recall it takes in ytrue first, so that's ytest versus our predictions. Run that. Looks like we're getting 83%, kind of as expected, since that's what we showed here in the example. And we can also plot the confusion matrix, pass in pipe, xtest, and ytest. And there you have it. Okay, so overall, it's actually pretty impressive that the model is performing this well, given that it's really just taking in the raw words. So are there some errors here? Yes, definitely. And you can see that overall we're getting around 80%-ish precision, recall, and accuracy. But when you take a step back and think about what the computer is actually doing, the ability to read in raw English words and figure out with about 83% accuracy whether that person meant the review to be positive or negative is really quite incredible, especially when you think about really hard problems like things like sarcasm in a review. It's pretty much almost impossible to catch from a machine learning perspective. But people are working on those problems, and natural language processing is a field that is rapidly growing and expanding. So I encourage you to check out other resources on it online, such as the latest publications on NLP and Python, if you're interested in this field. Okay, hope you enjoyed the project, and I'll see you at the next lecture.